So you buffer it, you drive the tone stack, and then since you've lost a lot, you boost that again. And in this case, before you boost it, that's where the volume control comes in. Okay? So again, this is something I don't know if they're ever made clear, but whenever you're designing a circuit, you almost never vary the actual gain of the circuit. You have fixed gain elements, and then you have voltage dividers in between to vary the overall gain. Okay? Because anytime you try to vary the gain of something, you modify the gain bandwidth product, and you can run into problems. That's changing the design on the fly, if you will. So the best thing is you design fixed gain stages, and then you put volume or gain control in the middle, so that none of your gain stages, you don't modify, this resistor, or well, it's certainly not that, because that modifies the bias as well. Or even with an inverting op-amp, you don't modify the gain. You modify the level somewhere else, and that affects the overall gain. Okay, so boost signals that were weakened by the tone stack. Now, when we talk about high gain amplifiers, when people say high gain, different communities may mean different things. If you talk to an RF engineer about a high gain amplifier, it probably means something that has like 30 dB a gain. But he doesn't care about the distortion. He doesn't want distortion. Distortion is bad, right? But with guitars, high gain often means very heavily distorted. So that makes the boogie amp on the lead channel is high gain. And what that usually means is you could take a given circuit, drive it with build a lot of gain into one stage, and drive it right into clipping. But typically, what is done instead is to combine multiple stages with a moderate amount of gain each, so that each gain goes a little bit more and more, and that gives you a different kind of clipping because you're in the nonlinear region of your devices. So whether you're going through a bunch of devices in one part of the curve versus one device in the more extreme part of the curve is going to give you a different sound. So high gains often have a number of stages, and each impart a linearity that most people find preferable. Again, it all depends on style. So the way a Fender amp is going to sound different than a Marshall is going to sound different than a Boogie, it's all part of the sound of each product. Okay, we'll look a little bit about the tone stack. The tone stack has 3 knobs: treble, middle, bass. Now, nominally you think about that as boosting the high end, boosting the low end, boosting the middle. And roughly that's true. And then sometimes they also have this bright switch, which actually, what does that bright switch look like? If you just look at that right there.
The bright switch?
Yeah, this is the bright switch right here. So ignore the tone stack on this side. You've got the volume control.
It's just a high pass filter?
Right, but what does it look exactly? Where else have you seen that schematic?
Well, that's the bypass passed around the volume to the guitar or something like that?
Exactly. It's the same circuit again being used. You've got a voltage divider with a capper on the top. So that is the bright switch. Now there's a fun program that you can download called Duncan Tone Stack Calculator, and I highly recommend getting this down. And what this allows you to do is it's a limited spice thing. That it allows you to go in and change the values, so you can set it up. It's got Fender, Vox, Marshall, and then a couple other ones. So some of these are really interesting. One of them I think is one of them similar to Bandexol, which is a standard bass treble knob on a stereo, and then one of them uses inductors and such. But you can go through and you can change the components if you want, and then you can set the bass, middle, and treble and see the frequency response. And then you can do a sweep, which effectively goes through a few fixed numbers of cases of each of them. And the interesting thing to note is, this is a sweep of everything. In every possible case, there is nothing where the mid-range is actually boosted, right? So you can't look at something and say, crank up the mid, turn on the bass and treble, and get a real mid-range boost out of the tone stack. Because the tone stack does not allow for that. But you will get a mid-range boost through the whole amplifier because every gain stage is a filter. So it's kind of interesting. Every so often people talk about, oh, why don't we build a tone stack pedal? Well, the problem with building a tone stack pedal is you can build this into a pedal very easily. You can put a couple buffer stages around it. But the tone stack only works because it's in an amplifier. You know? So, but I highly recommend looking at the Duncan tone stack calculator and playing with the different values. One of the things they got in there too is I think they have the big muff one, which is actually an interesting one. It's actually two simple single pole filters or single first order filters, and you basically, the tone knob is actually a blend between one or the other. You blend between high pass and a low pass. Okay, phase inverter. Like I said, it's got one point in life, and that is to generate an out of phase signal. So your circuit comes in here, and then the output is, excuse me, how does this one work? There are different types of inverter. This is a differential pair, long-tail pair, which is set up just like the input stage of an op-amp, right? It's a differential circuit. There are other circuits like the concertina, which is actually like a combination of the common cathode, common emitter thing, where you're taking two signals out of two different parts of the circuit. But this is the long-tail pair. It uses a differential amplifier to create the two out-of-phase signal, and it's one of the biggest modern ones. The concertina is an older one, and if you read through the Ultimate Tone book, you'll see both of those described in detail. You know, it's interesting to look at. But like I said, one of the current things now is to talk about balanced phase inverters, and where these two gain stages are matched phase inverters. These two gain stages are matched. From what I understand is that the inherent design of the long-tail pair eliminates the need for that. You know, because a good circuit design requires you less to worry about the parameters of the device you're doing, as long as it's within a certain range. Well, the long-tail pair is a good circuit design. It includes negative feedback, so it compensates for that. But people will buy what they buy. Power amplifier. This particular power amplifier uses a quartet of 6L6s. They operate, you've got two tubes operating in parallel. They're pretty much tied together. So these two operate in parallel, these two operate in parallel. And then they're push-pull. That this does one half of the wave and this half does the other half of the wave. They're tied together through the output transformer. Like I said, just about every tube amp needs an output transformer. And this is something I want to talk about. You have different kinds of output bias, and they're actually a little bit confusing. This design is called fixed bias. And what that means is that the cathode is tied to ground, and the bias of the set point of the grid determines the quiescent current, right? So you have a DC voltage on the grid that determines the quiescent current. You put the AC voltage, which is what you're amplifying. So if you bias it too hot, if the DC voltage is too high, you've got more of an overlap. Your class AB has a greater overlap region between the two halves. And if you're too cold, your voltage is too low, then you've got more of that crossover distortion we talked about last week, the class B type effects. So when you talk about biasing an amplifier, you'll often hear that when you need to change amplitudes, you need to bias them. What that means is if you've got a fixed bias amplifier, you need to set the DC bias on the power amp stage. You never worry about fixing the bias on the preamp stage when you change those. It's only the power amp stage. And the whole reason why is crossover distortion. And either if you're too cold, you get crossover distortion, or if you're too hot, you don't get it, but you're running your tubes hotter than they're designed to be run. So typically, there are different schools of thought as to how to bias. A lot of them just use the DC current and look at that. And that's important. You need to look at that to make sure you're not above or below the minimum and maximum. But you also want, I think the right way involves looking at the output and looking at the crossover distortion you get. Because, you know, if you bias it to some number that some book says good and you look at the output, you've got a lot of crossover distortion. What good is it? It's not as musical.
Professor,
yeah.
why do you add the tap on the power transformer? Like